Good morning, students. Today we're going to be talking about predicting single replacement products or products for single replacement reactions. So the first thing that we need to do is recognize that we have a single replacement so we can predict the products. The best way to do this is look and see we have a compound plus an element on the reactant side. It could also be written in the order of an element plus a compound. There is one exception to this, and that is we cannot have a hydrocarbon plus oxygen, because that's still a compound, but it is not the correct one. This is going to be a combustion reaction, and we're going to talk about that later. So, how do we predict the products of a single replacement reaction? There are 4 steps. The first step is we're going to identify if the element is positive or negative. And that just means we're going to look at the periodic table and we're going to check and see if the element is positive or negative when it's in a compound. Our second step is if it's positive, it will switch out or it will replace the first element in the compound. If it's negative, obviously it's going to switch out or it will replace the second element. And again, we're talking about in the compound. Our third step is, now that we know which element is going to be switched out, we're going to have to crisscross and reduce. Which means we're going to have to check charges and crisscross and reduce. This tells us we're going to have an ionic compound. And then our fourth and final step is we're going to go back and balance the whole reaction. So if we look at those steps again real quickly, we're going to identify if the element's positive or negative. If it is positive, it will replace the first element. If it is negative, it will replace the second element. We'll crisscross and reduce, and we'll balance. All right, let's work a couple of examples here. Our first example, we have Na2O plus Cl2. And I'm actually just going to rewrite this out here. All right, the first thing that we see is that we have a compound plus an element, which fits in to our design, right, of saying we have a single replacement reaction. So if we check our steps, our first step says identify if the element is positive or negative. So we're looking at Cl2. Is Cl, when it's in a compound, positive or negative? If you check your periodic table, chlorine is -1 when it's in a compound. So that means it's going to jump to the second step. If negative, it will replace the second element. So chlorine is going to kick out O in this compound. They're going to switch places because now O is going to be by itself and chlorine is going to be with Na. So let's go ahead and put O by itself. And when O is by itself, it's O2. Plus, now NaCl is going to be together, and we always list the positive element first, so we're going to put Na here and Cl here, +1 and -1. This is actually the next step. It says crisscross and reduce. Well, if we crisscross, we get a 1 there and a 1 there, right? But we don't usually put the 1s, so I'm just going to go ahead and erase these 1s so they're not confusing later. I'm also going to erase these arrows so that way, again, we're not confused later. Our last step says that we should balance. So if we look here, 1 O, 2 O's. So if I put a 2 out front, that gives me 2 O's. Now I have 4 NAs. How do I get 4 NAs? I put a 4 out front. I have 4 CLs. How do I get 4 CLs? A 2 there. And then finish it off with a 1 in front of the O2. All right, on to the next example. This one, we've got KBr, That is not a B. R plus F2, and we've got arrow. So now we check. Identify if the element is positive or negative. Excuse me. So we look at F, and we see that F, when it's in a compound, it's -1. So that means F, if negative, will replace the second element. So F is going to kick out BR, much like that first example. So F and BR are going to switch places. So BR is now going to be chilling by itself, and we know BR is diatomic, or part of Hofbrinkel. And then plus K, we always list the positive one first, is going to now be with F. So our next step says to crisscross and reduce. So we crisscross and reduce 1, 1. And the 1s come out because, again, we don't see those very often. You're still welcome to put them if you want, but you do not have to. And now we go back and balance. Our last step says we should balance. And this one's easier to balance. 1K, 1K, 1BR, 2BR. So we've got to put a 2 out there. Now we have 2K, so if I put a 2 out front, that gives me 2 Ks, 2 Fs. 1 there, and we're done. All right, our last one brings in quite a few steps. Number 1, it's written in words, so we need to translate from words to symbols first. So, calcium metal is dropped in a solution of iron 3 chloride. So, calcium is Ca plus iron 3 chloride, FeCl. Fe is +3, Cl is -1, so our formula should be FeCl3. All right, lose our charges there. Arrow. So now we see we have a single replacement because we've got an element plus a compound, which was this one right there. All right, element plus a compound. We check our first element, Ca. Ca, I guess we should be working with purple here. Ca is +2 when it's in a compound. So in this case, it's going to replace Fe. So Ca and Fe are going to switch places. That's going to give us Fe by itself. It's not diatomic, so we just leave it as Fe1 because it's monatomic. And now Ca, which is +2, will be hanging out with Cl, which is -1. So that step 3, says to crisscross and reduce. So we've got to put a 2 there, 1 there. So our formula for calcium chloride is CaCl2. Lose our charges there. And our last step says to go back and balance. So currently we have 1 Ca, 1 Ca, 1 Fe, 1 Fe, 3 Cls, 2 Cls. If we put a 2 there, that gets me to 6 Cls. And I can get to 6 Cls over here by putting a 3 there. Now I have 3 calciums, 3 calciums. All right. That's how you do it. One other question I've heard is that students are like, does it matter the order that I put these in? It absolutely does not. You could have written arrow 3 CaCl2 plus 2 Fes. As long as it's on the correct side of the arrow, it does not matter. All right, thanks. See you next time.